Continuing our discussion on radical equations, let's take a look at a cube root equation. Cube root of x plus 10 equals 4. I already have the radical isolated, so now I just need to raise it to the nth root, in this case the third root, to get rid of that cube root. So whatever I do to one side, I'm doing it to the other. The cube root and the cube will cancel. X plus 10 on the left, and then 4 cubed on the right. If you need your calculator, go ahead and pull it out. 4 cubed, 4 times 4 times 4 is 64. And then solving for x, we would subtract 10, and we get x equals 54. Let's check it. X plus 10 under the cube root, does that equal 4? Cube root 54 plus 10 is 64, and the cube root of 64 is indeed 4. So x equals 54 is our solution. Let's take a look at our next example, where now we have two radicals in the equation. Square root x minus 4 plus square root x plus 4 equals 4. Before I get too far into this, there are a couple of things I need to point out. The first one is a reminder about radicals, that if I have a radical x minus 4, this is not the same as square root x minus square root 4. Just like the exponents don't play nicely with addition and subtraction, neither do the radicals. They don't work. One simple example is if x is 1, square root of 1 is 1, and square root of 4 is 2. 1 minus 2 is negative 1, which is a real number, but the square root of 1 minus 4 is negative 3, which is not real. So we have a conflict here. They are not equal. Similarly, I cannot take that left side with the two radicals and try to square it and then square the other side. This does not work. I don't get to distribute this square exponent into a parentheses with a plus sign. There's no distributive property for that. So these are bad forms. I just want to make you aware of them, that they are common mistakes made, and so hopefully you can learn from other mistakes. So here we're going to take the first step, isolate a radical. It does not matter which radical I isolate. I'm just going to isolate the first one. So we have square root x minus 4 equals 4 minus square root x plus 4. And then the next step, raise both sides to a power to get rid of the radical. It's a square root, so I'm going to square both sides. When I square both sides on the right, I have a lot more work to do. Squaring on the left isn't too bad because the square root and the square cancel. So I'm going to take this square, and I'm going to use my box method. X plus 4 and 4x plus 4. So 4 times 4 is 16. 4 times negative root x plus 4, negative 4 root x plus 4, negative 4 root x plus 4. And then negative and a negative is going to give me a positive. Root x plus 4 times root x plus 4 will give me root x plus 4 squared, which is great because this simplifies to just be x plus 4. All of that will drop in on the right side. 16 minus, I have like radicals, so I'm going to add negative 4 and negative 4 will give me negative 8 root x plus 4, and then plus x plus 4 on the end from my last multiplication. And I can simplify some things on the right, but ultimately my goal on the right is to isolate this radical again. So I got rid of one radical, and now I only have one, so I need to get it by itself so that I can do this process again, square both sides. 16 plus 4 is 20, so I'm going to go ahead and simplify that before I start subtracting. Makes it a little bit easier to manage. And I want that radical by itself, so let's subtract x. Subtract 20. X minus x will cancel. Negative 4 and negative 20 is negative 24. Negative 8 square root x plus 4. I want that radical completely by itself, so I'm going to divide by negative 8. Notice there's no plus sign between the 8 and the radical. That's multiplication happening. -8 times the square root. Since I'm multiplying, I need to divide. -8 divided by -8, these are going to cancel, which is what I want. -24 divided by -8 will give me 3. And so now I need to solve the equation 3 equals square root x plus 4. I got to get rid of the square root, so we'll square both sides. 3 squared is 9. 9 equals x plus 4, a nice linear equation. X equals 5 is our proposed solution. Let's check it all the way back to the beginning. Square root x minus 4 plus x plus 4 equals 4. Big question mark, because we don't know. 5 minus 4 is 1. 5 plus 4 is 9. And if I take the square roots, square root of 1 is 1. Square root of 9 is 3. 1 plus 3 does indeed equal 4. And so x equals 5 is our solution.